In our last video, we defined the derivative as being the slope of the tangent line, the instantaneous rate of change, and the velocity. Now, we also used a long form of how you find the derivative. In this video, we are going to introduce shortcuts. The first thing we're going to do is we're going to look at notation. So if we have a function defined as y equals f of x, then we could either talk about the derivative as being f prime of x or y prime of x, or sometimes they use the notation dy dx. All three of those things means you're finding the derivative. Now let's look at some rules for how we take the shortcut of the derivative. Now if you have y equals f of x equals some constant c, then the derivative of that is 0. I'll give you an example. So if we have that f of x equals 3, the derivative of that, since 3 is just a constant value, there's no variable there, the derivative of that is 0. What that means, of course, is that if you're on your graph at some point 3, derivative of 0 means the slope is 0. And of course, if you have the line y equals 3, it does have a slope of 0. So the derivative of just any number is 0. The power rule states that if you have x to some power, then the derivative is that power n times x to the n minus 1. So you will take whatever the exponent was, multiply it by the x, and subtract 1 from the exponent. The constant multiple property says that if you want to take the derivative of f of x, and f of x is just some number k times u of x, which is your function, and the derivative will just be k times u prime of x. So you just take that constant number times the derivative of the function. And the sum and difference property merely states that if you're adding two expressions or subtracting them, you would take the derivative of each. So the derivative of f of x here, where f of x is u of x plus or minus v of x, would be u prime of x plus or minus v prime of x, the derivative of each of those. Let's make these make sense by doing some examples. If we look at A, or number 1A, it says find the derivative if f of x is 24. Well, we learned from our constant function rule that the derivative here is just going to be 0. So the derivative of a number is 0. Similarly here, y prime is asking for the derivative of y equals -3, so that will also be 0. In example 2, we have x to a power. So it says f of x equals x to the 6th. So the derivative there will take the 6 and multiply it by the x, and we'll subtract 1 from my exponent and get 5. So the derivative is 6x to the 5th. Similarly here, dy dx means find the derivative of y equals x to the -4. So we're going to write dy dx would be, we'll take that -4 times x, and we subtract 1 from -4. Now you have to be careful. When you subtract from a -4, you're going to get a -5. So our answer for the derivative is -4x to the -5. Let's do it here. Now here, if I have 1 over x, this can be rewritten as x to the -1. So when I take the derivative of this, we'll get f prime of x would be a -1x to the -2, because we subtract 1 from that exponent. So it looks harder, but it's really just the same process. Now when we look at B, where we have y prime, we want to find y prime, if y equals the cubed root of u squared, we have to turn this to an exponent. So the cubed root means a fractional exponent with 3 in the denominator of the exponent, and 2 is the power, so that'll be in the numerator. We rewrite y as y equals u to the 2/3 power. So taking its derivative, get 2/3 u to the, what do we get if we have 2/3 and subtract 1? Let's do that over here. 2/3 minus 1. We have to get a common denominator. So we'll have 2/3 minus 3/3. That is the same as 1, an equivalent. So when we subtract this, we'll subtract the numerators and get 2 minus 3 is a negative 1/3. So this answer is y prime is 2/3 to the negative 1/3 power. Now we have to do a similar trick on C. We want to find the derivative with respect to x of 1 over the square root of x. Now recall, if we had just the square root of x, that would be x to the 1/2, because it's the square root, this index goes in the denominator. But because this whole expression is in the denominator, 1 over the square root of x would be like 1 over x to the 1/2, wouldn't it? And if we have it in the denominator, the way we write that is the negative power. Just like we did here, we called this x to the negative 1. So this will become 1, let's see, become x to the negative 1/2. That's what we really have here with this expression. So if we're taking the derivative of that, we're going to get, will equal a negative 1/2 x. And if you subtract from 1 from this, you get a negative 3/2. You have to remember how to subtract exponents. Let's go ahead and look at example 4 and 5. So in example 4, in this case, we're taking the derivative of x to the 6. So we use that power rule, but we also have a constant in front of it. So it's going to look like this. F prime of x, excuse me, would be the 4 times the derivative of x to the 6, which is 6x to the 5th. So we're going to get 24x to the 5th. Our shortcut, of course, then would be to take your exponent, which was the 6, times the coefficient. So 6 times 4 was 24, and we subtracted 1 from our exponent to get x to the 5th. We'll need to rewrite this, and we have to be careful when we do this. The x is the only thing being taken to the 4th power in this denominator. So if I rewrote this, it would be y would be 1/3 x to the negative 4. So the 3 isn't being taken to the 4th power. We would write that fraction as 1/3 x to the negative 4. So now when we take its derivative, I haven't taken the derivative yet, I've just converted it to an exponent. What we'll get is y prime will be, we'll take the negative 4 times the 1/3 and get a negative 4/3 x to the negative 5, because we subtract 1 from the exponent. We have to do something similar here. We're going to rewrite this as y equals 1/12 t to the 4th. Taking our derivative, or the way they wanted us to write it was dy dt. The 4 will multiply by the 1/12 and give us 4/12. But we know that that is equivalent to 1/3. So we're going to go ahead and reduce that fraction to 1/3. And if we subtract 1 from my exponent, we'll get t to the 3rd. That would be our derivative in C. In D now, we have to be careful once again. We can rewrite this expression here as 0.9x. Now, since this x is in the denominator, if I write it in the numerator, I have to make it negative. And since it's the cubed root, that would be to the 1/3 power. Now, taking the derivative of this, dx would equal, we'll take the negative 1/3 times 0.9, and negative 0.3 x. Now, when we subtract 1 from my exponent, the negative 1/3 minus 3/3 is going to give us a negative 4/3. So that would be our derivative here. Let's go ahead and hit example 5. In example 5, we want to find the derivative of this multi-termed expression. Computer's going a little crazy. Apologies. So we'll just simply take the derivative of each term. In A, it says f of x is 3x to the 4th minus 2x cubed plus x squared minus 5x plus 7. We just take the derivative of each individual term, so it makes it quite simple. And our derivative will be 12x to the third minus 6x squared plus 2x to the first minus 5, and the derivative of a constant 7 would be 0. So that part goes to 0, and that is our final answer. Let's look at B. Here we want to find the derivative for y equals 3 minus 7x to the negative 2. So we'll write y prime. The 3 will become a 0, and then negative 7x to the negative 2, we multiply our negative 2 times negative 7 and get a positive 14. X to the negative 3 because we're subtracting 1 from the exponent. All right, I hope those were helpful. In our next video, we will continue with some of these shortcuts. Thanks for watching.